All right, number 10, we're going to find the derivative of g of w. So we're going to be using the differentiation rule that the sum of the derivative is the derivative of the sum. And so at each stage we'll just use the power rule. And just to kind of help, I'm going to put a 1 exponent here. So when we do g prime, we're just doing the power rule. So we're going to multiply times 9, the 8w to the 9th power. We're going to subtract 1. So that's that derivative. And then we're going to multiply times 2. So multiplying that constant down, the 3w to the 2nd, and then you subtract 1 from that exponent. And then we'll multiply times 1, 20w, and we'll subtract 1. So 1 minus 1 will be 0. So we'll get our g prime. 9 times 8 is 72w. That'll be to the 8th. 2 times 3 will give us 6. W, 2 minus 1 will just be a 1, understood. And then 1 times 20 will give us 20, and then w to the 0 is just 1. So we'll just end up with this expression. That's 6s, 6w, 116w. Okay, 72w to the 8th plus 6w plus 20. All right, number 11. The distance an object falls when released from rest under the Earth's influence of Earth's gravity. No air resistance is given by 16t squared. D is measured in feet. T is measured in seconds. Rock climber sits on the edge of a rock wall vertically. Carefully observes the time it takes for a small stone to fall from the ledge to the ground. We're going to compute D prime, and then what units are associated with the derivative, and what does it measure, and then if it takes 4.5 seconds for the stone to hit the ground, how high is the ledge, and then how fast was the stone moving when it strikes the ground in miles per hour. So we are going to take our function, and first we're going to find the derivative, and it tells us that it is measured in feet, and then this will be per second. Okay, so we have dt is 16t squared. Alright, so when we do d prime of t, we'll multiply times 2 of the 16t and 2 minus 1. So that will give us 32t. This will be our derivative, and that will be in feet per seconds squared. Okay, so the units associated with the derivative are going to be feet per second, and it measures the velocity, the speed of the stone. Okay, the ledge is blank high. So the D is the distance, and if we know how long it takes, because this function is in terms of time, this thing hits the ground at 4.5 seconds. So we're going to just take our function and plug in the 4.5 seconds that it took to hit the ground. So it'll be 16 times 4.5 seconds squared, and then this will give us the distance how high this is. Let me just pull up the basic calculator. 4.5 squared times 16. So that gives us 324 feet. So this cliff is 324 feet high. And then we want to know how fast was it moving, so the velocity when it hits the ground. So once we have our derivative tells us the velocity. We just plug in the 4.5 to our derivative function now. So if we find, this will give us how fast it was going, which was 32 times 4.5. So 64, 128, and 16, 38, 144. So this thing was going 144 feet per second. They actually want to know how fast this was moving in miles per hour. So right now our units are feet per second and they are asking miles per hour, so we have to do a conversion. So there are 5,280 feet in 1 mile. Okay, I want to put my feet on the bottom. That'll cancel out feet and make it miles. And then an hour, there are 3,600 seconds. So that's 60 seconds in a minute times 60 minutes in an hour. 30, and I need this on top actually. I want seconds on top because that's going to cancel out. So I need the 3,600 seconds and then per hour on the bottom. Okay, so we're going to take our 144 divided by 5,280 and then multiply by 3,600, and that will give us miles per hour, because the feet will cancel out feet and then the seconds will cancel out the seconds on top and bottom, and that will give us this rate in miles per hour. So I'm going to take the 144 and divide it by 5,280 and then multiply the result by 3,600, and that gives us 98. It says round to the nearest integer, so we'll say about 98 miles per hour.